At the American Geophysical Union Fall Meeting, the Earth and space science community gathers both in New Orleans and online to network and connect and exchange the latest thinking about our world and beyond. The Fall Meeting program explores a wide range of topics such as climate change, solution science, equity in the research community, and much more. Since 1919, AGU's members have explored the deepest oceans and the furthest planets, and AGU TV is here to cover it all. Welcome back to the fifth and final episode of AGU TV. We hope you've enjoyed all of the great sessions, networking, and activities that the meeting has offered. On our final day, we again join our co-host, Nikandra Norwood from the Convention Center in New Orleans to explore the AGU Fall Meeting's theme, Science is Society. Nikandra, what do you have coming up for us here on our final day?
Thanks, Autria. You know, we have just a few more great interviews on today's episode of AGU TV. We're joined by Lauren Haygood of AGU's Voices for Science cohort, Caitlin Hall on incorporating policy into your work, and Claire Cannon on environmental sociology. So be sure not to miss out on our final episode.
Thanks again, Nikandra, and we are also rounding out the rest of our final episode with a look at a few really interesting projects in areas such as early flood warning and AI weather prediction. So be sure to stay tuned for that.
Well, welcome back, AGU members. We are talking now with Lauren Haygood. She is a graduate student at the University of Oklahoma and also an alum of Voices for Science. Thank you for joining us.
Yeah, thanks for having me.
So tell us how that experience has really helped you so far in your career.
Yeah, so at least doing Voices for Science, it's really helped me engage with policymakers, engage with the general Oklahoma community. I was able to start a community science project dealing with water quality and incorporate it as a public policy initiative. And I've been able to continue that with graduate school at Oklahoma State University.
So why is it important for scientists to be thinking about how to best communicate those impacts of their work with the public?
There's so much information out there now with technology, and there's also a lot of misinformation out there too. So if we as scientists can figure out the best techniques for sharing our work with specific communities, then it'll really help the advancement of science and help towards public policy initiatives.
There are some consequences to ineffectual scientific communication. Let's talk about how, it's important that we have that clear message.
Yeah, so if we're not able to effectively communicate what we do, then that could sort of impact the amount of trust that we have, and then also with the amount of just information out there in general, and people can just search on Google for something and find something. If we're not effective in our communicating methods, then the stuff we're trying to share could just get lost in the noise that's out there versus kind of being in the forefront.
Now, some AGU members may not be that familiar with Voices for Science. You were a member of the 2020-21 class. Tell us a little bit more about the program and how you can get involved.
Yeah, so it's a great opportunity, great networking, great way to build relationships and do collaborative policy communication work. And even if you get selected for either the communication track or the policy track, you still learn the other track's methods. So like I was still taught science communication techniques, even though I was in the policy track.
And tell us, about your work and what you're going to be using that background to tell folks about.
Yeah, so I started a community science project because they have a micro grant that you can apply for. It's a Voices for Science, and use that to start a community science water quality public policy initiative. And I don't think I would have actually been able to do that or felt like I could do that if it wasn't for having some months in the Voices for Science program, because I had the support of Voices for Science. Was kind of like, I'm gonna try it and see what happens. And over 500 people have been involved now, and teachers even incorporated it into their classroom. And I'm like keeping it going and sort of figuring out new ways to make it more effective in Oklahoma. So it's open doors that would not have been opened otherwise as well.
All right, well, thank you so much, Lauren, for sharing your experience with us today, and maybe hopefully inspiring some of your fellow AGU members to get involved in this program.
Yeah, well, thanks for having me. This was fun.
When it comes to community science, international collaborations are the key to harnessing our research efforts and utilizing the data to create a better world for all. At the forefront of that is M2 Lines, a team using interpretable machine learning across different disciplines to leverage recent advances in data science. Let's see how they do it.
M2 Line is a large collaborative effort that includes 9 institutions, including 3 modeling centers. We're focusing on improving 3 climate models.
The goal of M2 Lines is to use machine learning to find missing processes in our climate models, but we need subject experts to link these machine learned structures to the atmospheric, oceanic, and sea ice components.
What makes M2 Lines so unique is that it's applying machine learning to traditional physics problems. So things that used to be maybe derived in a semi-empirical fashion now can be driven directly from the data.
We're explicitly trying to use machine learning as sort of an auxiliary tool in the scientific discovery process to discover what information is needed to make predictions, and then also to sometimes discover equations that will generalize better.
By improving multiple models at once, we have more confidence that we're actually fixing the physics for the right reasons.
Going blue means seeing green. Gulf Blue is a globally recognized organization dedicated to driving the blue tech economy in the Gulf of Mexico. Thanks to expansive maritime infrastructure and the launch of a new blue tech innovation, the coastal community is thriving and the quality of life is off the charts. Let's see how going blue could be good for all of us.
Gulf Blue was originally launched to be the transformational kind of economic driver for the Mississippi Gulf Coast. We are pioneers in a lot of the blue economy, shipbuilding, fisheries, other aspects, and for us all to work together across the entire region to help promote the region.
USM actually founded this idea of Gulf Blue as a brand for the coast of Mississippi and the Gulf Coast area. When we recognized that the innovation sector of the Gulf Coast needed a branded image that we could tell the rest of the world what is going on in terms of science, technology, the research and development underway.
A company can come in and it provides easier access to our facilities, whether it be a prototyping shop, one of our research vessels, some of our human capital aspects with research scientists or engineers, as well as access to a network of capital that can potentially be of assistance to a company.
AGU TV is brought to you from the 2021 AGU Fall Meeting. You can find us in person at the Convention Center in New Orleans, in select hotels, as well as on the homepage of the meeting platform and online. From award winners to research center visits, it's all on AGU TV.
Well, welcome back, guys. We are here with Caitlin Hall. She's an assistant professor at the University of Arizona. Caitlin, thank you so much for joining us today.
Oh my gosh, thank you so much for having me here.
Now, you hold a lot of roles here in AGU. Tell us a little bit about it.
Oh my gosh, when I first started at AGU, I was so overwhelmed. I felt like there were so many things I could do and I just wanted to do everything. So I was a Voices for Science Fellow, a Thriving Earth Exchange Fellow, and I also got involved in a lot in leadership positions within the hydrology section as an early career scientist representative, and now with the Justice, Equity, Diversity, and Inclusion Technical Committee within hydrology.
And that's one of the focuses that you'd really like to look at is, helping students kind of focus some of that energy and really put it to work.
Yeah, absolutely. I think that students have so much energy and so much drive to do things, but they don't know where to put it, or they have these amazing ideas and they don't know who to ask. And I think imposter syndrome really plays a massive role in that. And so what I try to do is create safe places for students to get involved, try things, try their ideas, fail safely, and try again.
I think we always, you kind of hear that about science. It's like, oh, well, part of it is failing.
Oh my gosh, it's all failing.
But that's how we learn.
Absolutely. That's something that I feel like all scientists are really afraid of. Failing is just gonna happen, and it's how you come back from it. It's like, I've learned something and I just won't make that mistake again. As soon as we, as scientists, especially early careers, get more comfortable with that, I think that they're just gonna soar.
And you work with the Arizona Science Policy Network. Tell us about that mission.
So I founded the Arizona Science Policy Network, honestly, because I had a lot of people coming to me and they're like, I don't know what I'm doing. And I was like, I don't know what I'm doing either. Let's do it together. Our whole goal is to try and involve more early career scientists in policy at local and federal levels. So we've helped draft legislation and also have helped community groups understand different science issues and how it can impact them so that they can better advocate for themselves as well.
That is a difficult process. And we've talked a lot really through the conference, everybody, about making sure that the science can be communicated to the layperson and for them to know how to use it.
I think journal papers are excellent for scientists, but they are arduous to get through, let's be real. And so I think that making sure that your take-home lessons are shared in a way that is understandable and also helps give guidance is very important.
And so another program that you've been involved in is University of Arizona's Future Earth Resilience minor program. Tell us a little bit about that.
Yeah, so it's a brand new minor program at the U of A, or the University of Arizona, and it grapples with what does resilience mean? We've shaped it off of the United Nations Sustainable Development Goals because resilience isn't just climate change resilience, like can we protect against natural hazards? We also need to make sure that resilience is equitable, that everyone on the planet can be resilient and has the economic or infrastructure or health or civil rights resources that they need to actually be resilient.
Tell us a little bit about how scientists can use that and really put it out there in the community.
Scientists need to start by listening. You need to work with community members and their values and go in with your ego a little check to say, I'm here to listen and understand before I just hear this is the solution.
It makes so much sense talking about finding out what that problem is, and even though brilliant mind has a great solution, if it's not going to work for the community, they're probably not going to do it, right?
Yeah, and it might not work for them. And what if they never use it? Why don't we just work together a little bit more and listen? Scientists really need to listen rather than just assume that they have the best technology to solve problems.
That's a great note to end on. It's great to meet you. Thanks for joining us today.
Awesome. Thank you.
From going blue to seeing red, at Krafla Caldera in northern Iceland, scientists are preparing for what could be one of the most ambitious geoscience projects ever undertaken. To discover the secrets of magma and to unlock the potential of the Earth's heat, they have begun work on the Krafla Magma Testbed. Let's check out this hot new mission.
Krafla Magma Testbed is a project where we want to drill into magma on purpose.
It's a mission towards inner Earth, and this is something that has never been done before.
Krafla in particular is one of the most researched volcanoes in the world.
It's the sort of place where you can actually do things with the magma in a safe way and in which the infrastructure is available to do the work. There's nowhere else on the planet.
We've got live rhyolite magma sitting there where we can get at it.
We know it is not primed to erupt, giving us the opportunity to drill into, instrument, sample and manipulate magma.
We'll be able to make it a real, unique, international natural laboratory.
It will create the opportunity to study volcano monitoring and hazards and geothermal energy, direct magmatic energy.
Hopefully in 2024, we'll be ready to actually drill this first hole. I'm totally focused on this right now.
When the threat of flooding is imminent, advance warning is key to saving lives and reducing damage. The Urban Flooding Open Knowledge Network is an informational infrastructure built using knowledge graphs aiming to extract structured content from the information scattered across open source geospatial data sets and hydrologic models. Let's check out how taking a holistic approach for a better understanding of the short and long-term impacts of urban flooding can mitigate the human and economic loss.
Flooding impacts everything within the urban multiplex: the power grid, the transportation network, the natural systems, The Urban Flooding Open Knowledge Network is a common infrastructure that supports data from several urban systems and provides flood forecasts at each individual feature across the city.
So our principal case study right now is looking at the scale of CONUS and at the feature level. So we're trying to index every building, every road, every feature that we might be interested in and provide flood forecasts at those locations from NOAA's National Water Model.
We can really predict the depth of inundation across any location in the United States that's included in the Urban Multiplex inventory. And we're using a lot of tools that can provide information in real time and also use probabilistic information based on historical flood events.
What we want to do is be able to help emergency responders, homeowners, business owners make those really impactful decisions that preserve not only their property but their lives.
It has been a great week of networking, idea sharing, and hearing from the best and the brightest in the field of earth and space sciences. So as we wrap up this incredible meeting once again, we wanted to know, what have you been most inspired by at the fall meeting this year?
I have really enjoyed getting to see people's presentations in person, like people I've seen present at other conferences, and actually getting to see their work and like the progress they've made, and I found that really awesome.
I think the same thing, the fact that you see your co-workers and geologists, geophysicists in person, I think that is a huge, I would say, improvement, especially living in the midst of a pandemic. So this is great, yeah, very well organized.
What I really found inspiring is that the field I work in, which is remote sensing of rivers, it's moving forward by leaps and bounds. Every year it seems like we're discovering new things, and it's just a really exciting time to be part of it all.
I am really inspired by the focus on science and society and using all of the amazing science that's here to advance solutions and actually make it applicable and useful and really urgently needed. And it's really inspiring that the AGU is recognizing that in such a big way.
And we're back with Claire Cannon, an assistant professor at UC Davis. And Claire, thank you so much for joining us today.
Thanks so much. I'm excited to be here.
So tell us a little bit about what environmental sociology is and why it's important to folks who work in the natural sciences.
This is a great question. So environmental sociology is just the study of interactions between society and the natural world. People take this in a lot of different directions. So people use environmental sociology to look at issues related to environmental justice, global political economy issues, so looking at carbon emissions, understanding transportation, supply chain, and these sorts of things, but really trying to understand, what is the social cost of these global dynamics and how do they relate to the environment?
How can we understand climate science and environmental justice through a feminist lens?
If we have to boil it down to kind of what is it that we mean by feminist, we really mean thinking about power and thinking about how power operates both in how science is produced, how it's received, how it gets taken up in different policy, legislative, and community action spaces. There's this idea within feminist theory and methods called standpoint, which basically is where I'm socially located. So the different axes that make up my social identity inform how I view the world. There are a few kind of key points, I think, for advancing climate science and environmental justice. So one is acknowledging the embedded context in which our science is occurring, identifying where power is embedded and operationalized, situating, so again, coming back to this idea of standpoint, so understanding that researchers have access to different resources, but there are also limitations. And then finally, centering. So a lot of my work in environmental justice and climate science, and I encourage others to do this, is really centering who benefits from this science and thinking about really centering their experiences and trying to learn from their knowledge because they know their communities better than anyone else.
Tell us more about your research into environmental exposure and the related health outcomes in the Central Valley.
So I use a community-driven, research-engaged approach, community-based participatory action research, and I have community partners in the Central Valley, El Pueblo, and Green Action for Health and Environmental Justice. And we've been leading a study in this little farm worker agricultural town in the Central Valley called Kettleman City. And together they identified concerns that they had about their environment that could infect their health. And one of the things that makes Kettleman City unique is that it hosts one of 2 Class 1 hazardous waste landfills in the state of California. And so these types of landfills typically take waste from oil refinery processes. So it's really hazardous. And so the community has been, since this landfill went in, really concerned about, are there health outcomes from this environmental burden?
What can AGU members gain from taking an intersectional approach to their research?
An intersectional approach will really increase the reach, rigor, and relevance of the science that AGU members are doing. It helps us advance our science by understanding that people are differentially affected. This is relevant to you because you can think about how these dynamics inform the natural world, and people interact with the natural world, and people oftentimes decide what happens to the natural world. And so being able to bring an intersectional approach is hugely important.
Thank you so much for joining us, Claire.
Thanks very much.
With the recent rise in global weather catastrophes, the need for reliable and trustworthy weather prediction systems has never been greater. The National Science Foundation's AI Institute for Research on Trustworthy AI in Weather, Climate, and Coastal Oceanography is a convergence center that will create trustworthy artificial intelligence for environmental science. Their work aims to revolutionize prediction and understanding of high-impact weather and ocean hazards and benefit society by protecting lives and property. Let's see how it works.
AI2ES is a brand new type of institute. We aim at building trustworthy AI, a whole process, a whole cycle from the development of the models, their applications, and how people are using them. And we're doing it for weather, climate, and coastal.
We're going to have a truly personal relationship with our weather. We're going to be able to get an accurate, trustworthy prediction out of our phone. And we're going to be able to know what's going to happen around us. We're going to be able to improve our understanding of how the climate is changing and all of that. There's going to be a true revolution in how these models can be able to predict everything, because that's a lot of what we're developing.
The Institute pulls together some of the country's top experts in weather, climate, and coastal oceanography from universities and national labs. It's a really impressive group.
AI2ES is built on cycles, and one is workforce development. We're creating the future leaders of AI.
The more ideas, the more unique people we bring in, the more interesting solutions we're going to find.
Community science for me is community-led priorities, addressing those priorities, working with communities to find out what their needs are and connecting them to the science that can help address those needs.
It occurred to me that a lot of science communication was about trying to reach out to people and tell them how great science was. And I thought it would be really interesting to try the other way, asking people what they cared about, asking people what they were interested in, and then finding ways to do science that connected to that and built on that interest. The idea with the Community Science Exchange is really two. One is, a lot of times scientists do this work and it's difficult to find a place to publish it. It's difficult to find a way to share it that carries kind of academic weight and academic credibility. And that's a barrier to doing the work. The second thing, and probably the more important thing, is to create an opportunity for people to learn from each other and to share what they're doing with each other and to improve the quality of the work by being part of a network and an exchange.
At AGU, we really think that the future of our planet depends on addressing local and planetary issues at all levels and finding solutions to the real world problems that will be continuing to come up for the rest of time. So we think that focusing on solutions for real world needs has to come from working together with communities to find out what are the needs those communities need to have addressed.
And it isn't just AGU, which is kind of a cool thing, right? We recognize that when you're doing community science, it isn't about a specific discipline. there is no community that has a priority that maps neatly to a tiny, narrow discipline. So we realized we had to collaborate. So we're working with the American Public Health Association, the Mexican Geophysical Union, the Anthropological Association of America, and the Citizen Science Association on this new journal, Community Science.
We are all connected to each other in so many ways that we don't fully understand, and we'll never have a full understanding of it, but knowing more and more is interesting. And I think over time, I've realized that it's not just about the learning for learning's sake, but about how we can use the knowledge that's gained and use it for good and take the cues from those local communities to figure out how to use it.
For too long, science has had sort of walls around it. Not always intentional, but they were walls that kept people out. Certain people didn't have the resources to ask their scientific questions. Certain people didn't feel welcome in the scientific community. I think we're on the cusp of seriously thinking about what we can do to remove some of those walls and welcome people into the science community.
Now to another National Science Foundation initiative and a partnership with the state of Delaware that's aimed at assessing major threats to Delaware's water quality. Project Wicked is working to develop viable technological and policy solutions for meeting the challenges imposed by them. Let's head to the first state to see how it's going.
Project Wicked has a fun name. It stands for Water in the Changing Coastal Environment of Delaware. And one of the things that I love about the name Project Wicked is it talks about the challenges of water given the changes that we are seeing.
When we look at the whole Wicked groups, it is complete diversity, complete inclusion. It's like amazing. Every sector that you can imagine in Delaware is part of it.
We're lucky in Delaware because it's a small state, and so we can develop strong relationships between academic institutions, between communities, the government, the private sector, etc. If we communicate with each other, then we're able to identify the needs of the state and the communities.
Models created here in the state of Delaware can ultimately impact our region, our nation, and ultimately the world.
Thanks, Nikandra. Well, that is it for us here at AGU TV. Whether you took part in AGU Fall Meeting in person or virtually, we hope you've had a chance to explore all of the fascinating advances in Earth and space science, as well as meet a few new faces. Don't forget, you can watch AGU TV on the meeting app and platform, in select hotels, and always online. Thanks again for joining us. We can't wait to see you right back here next year.